Welcome back, children. Now let us move to the worksheet number 4 of laws of motion. Here we begin with the first numerical, that is, a force of 50 Newton acts on a body for 10 seconds. How much is the force given? 50 Newton. Time is given as 10 seconds. What will be the change in momentum? Children, as we know that if momentum is given as mass into velocity, okay, and general formula for linear momentum is mass into velocity. Suppose if initial velocity was taken as u1, u and final velocity is taken as v, then change in initial momentum will be mass of the body into initial velocity and final momentum of the body equals to mass of the body into final velocity. Then change in momentum can be given as final momentum minus initial momentum, that is equals to mv minus mu. So what is the correct one? Change in momentum. Formula for change in momentum is P2 minus P1, which is equals to mv minus mu, or simply it can also be written as m times of v minus u. What is that? M times of v minus u. So this is the formula for change in momentum. So it asks you to find out the change in momentum. But suppose in terms of force, if F is the force acting on the body, then change in momentum can also be written as the product of force and time. This is called as your impulsive force and the product is called as your impulse. Impulse is equals to product of force and time. Because force can be written as change in momentum upon time. Simplicity, instead of F, we can write it as change in momentum upon time. According to Newton's second law of motion, the rate of change of momentum is called as net external force. Change, that is rate of change means change in momentum upon rate means time. mv minus u by t equals to force multiplied by t. This t and t gets cancelled. So J is equals to m into v minus u by t into t, or equals to m into v minus u. Okay. So either you multiply force into time, you get the impulse. Whether you multiply rate of change of momentum with the time, you also get the same value, impulse. So clearly, as LHS is equal, we can equate RHS. Therefore, we can clearly say that impulse is equals to product of force and time, which is also equals to change in momentum, which is also equals to change in momentum. Okay, just now we discussed, because F equals to mv minus u by t into t gets cancelled, you are left with m into v minus u. So now what is given? Force is given as 50 newtons and time is given as 10 seconds, and you are asked to find out the change in momentum. So this is your change in momentum. Here is the product of force and time. Therefore, change in momentum is equals to product of force and time. How much is the force given? 50 Newton. Time is given as 10 seconds. Hence, change in momentum is 50 into 10 is found to be change in momentum delta P equals to 500 Newton. So, remember this formula, children. Impulse is nothing but F into T, product of force and time, which is also equals to change in momentum. So, as you are asked to find out change in momentum, simply find the product of force and time. So, your answer is 500 newtons. So, option number 3 must be true. Let us move to the next question, children. Second one, kg meter per second is the unit of. What is the unit of force, children? Unit of force is, formula for force is mass into acceleration. So, mass measured in kg, acceleration measured in meter per second square. So, but here it is asked regarding kg per meter. So, this must not be true. Velocity, for units of velocity is meter per second. So even this does not go with kg meter per second. Acceleration measured in meter per second square, but there it was given as kg meter per second. Now coming to the impulse. Impulse is nothing but change in momentum, and units of momentum or change in momentum, whatever it is, its units is nothing but I can explain the same in two different ways. M into V minus U. Okay. So whether it is V minus U indicates the physical quantity, velocity. So mass is measured in kg and velocity measured in meter per seconds. Hence, goes good. Or else the same impulse can also be written as force into time. Units of force is nothing but mass into acceleration into time. Mass is measured in kg, acceleration measured in meter per second square. Time is measured in seconds, goes cancel. So you are left with kg meter per second. So whether you go with this formula or this formula, you get the result as kg meter per second. So which among them is the true answer, children? Kg meter per second is the unit of impulse. Is the unit of impulse. So fourth option must be true. Okay. Now moving to the third question. Change in momentum is same as. Just now we have discussed change in momentum is same as impulse, which is also same as the product of force and time. So change in momentum is same as impulse. Change in momentum is same as impulse. Now look at the fourth question, children. What will be the impulse on a body at rest when acted upon by a force of 4 Newton for 2 seconds? Impulse is equals to product of force and time. How much is the value of force given? 4 Newton. Time is given in 2 seconds. So this is equals to 8 Newton second. How much is the impulse? 8 Newton second. So option number 3 is true. Question number 5. A 250-gram ball moving at 20 meter per second is stopped by a player in 0.01 seconds. So maybe it is confusing. So let us write the given data. So mass is given as 250 grams. Let us convert this in SI units. In order to convert in SI units, grams to kgs. To convert grams to kgs, you have to divide this with 1000. So now after simplification, 0 gets cancelled and 25 goes 4 times. This will be 1 by 4 kg. Mass is given as 1 by 4 kg and moving at 20 meter per second. Initially it moves with speed 20 meter per second. Initial velocity is 20 meter per second. Stopped by a player in 0.01 second. Time is given as 0.01 second. What impulse did the ball exert onto player's hand? And what else is given? Is stopped. Stopped means final velocity is 0. You are asked to find out the impulse. So formula for impulse, J is nothing but J is equals to force into time, which is also written as product of change in momentum. Is that impulse is equals to product of force into time or simply change in momentum. So change in momentum can be given as M into V minus U. So J is equals to F into T, which is also equals to change in momentum, and change in momentum can be written as M times of V minus U. Therefore, J indicates your impulse. Here J is nothing but your impulse. Hence, impulse is equals to mass. What is the value of mass given? 1 by 4 kg. Final velocity 0 minus initial velocity is 20. So this is equals to minus 20 upon 4 and this is equals to minus 5 Newton second. So from this I have considered the unit. Force is measured in Newton and time is measured in second, Newton second. Okay, plus and minus only indicates the direction. So impulse did the ball exert onto player's hand is. So the ball is moving, the player was stopping. So this ball exerts the force on the man is given as in the opposite direction, that is 5 Newton second. Minus indicates only direction on which it is acting. And magnitude of that is nothing but 5 Newton second. Okay. So now moving to the last question, children. Sixth one, a body of mass 100 kg moving straight line with a velocity of 30 meter per second. Mass is given, velocity is given. Moves in opposite direction with a velocity of 20 meter per second after hitting a wall. So let us try to visualize this. A wall is there and this is a straight line. Now what was given is that a body of mass 100 kg moving straight line with a velocity of 30 meter per second. So ball is there. Yeah. This ball moves straight. Initially the position of the ball was here. Okay. This ball moving straight and again coming back. So how much is the mass of the ball given? Mass of the ball is given as 100 kg. Mass of the ball is given as 100 kg moving straight line with a velocity of 30 meter per second. Initial velocity of the ball is given as 30 meter per second. So whenever it is moving, it moves with a speed in this direction. Let us take it as positive. So positive direction 30 meter per second. Now, moves in opposite direction with a velocity of 20 meter per second after hitting the ball. Once this ball reaches here, once this ball reaches the wall, it again moves in opposite direction. Until here moves with 30 meter per second, returns back at 20 meter per second. Returns back at 20 meter per second in the opposite direction. This is plus 30 meter per second, positive direction, negative direction. This is taken as minus 20 meter per second. So this is your initial velocity and this is your final velocity after hitting the wall. So V is given as minus 20 meter per second. What is the magnitude of impulse? Children, as we know, the magnitude of impulse is nothing but change in momentum. How much is that? Change in momentum. So what is change in momentum? M times of V minus U. So substituting all the values we have, mass is given as 100 kg, final velocity is given as minus 20 meter per second, minus initial velocity is given as minus 30. So this is equals to 100 times of minus 20 minus 30 is minus 50. Finally, you are getting it as minus 5,000 Newton second. How much is that? Impulse is given as minus 5,000 Newton second. Magnitude of the impulsive force is given as, magnitude means no need of taking the direction, only magnitude, numerical value is 5,000 Newton second. So where is the correct option, children? Option 2 must be correct. It is impulse. Magnitude of the impulse is considered as 5,000 Newton second. So with this we have completed with the worksheet number 4. And now let us move to the next worksheet in the next class. Until then, take care. Thank you.